geometry and trigonometry, which I'm going to take one after the other. So the first one I'll be talking about is geometry. Geometry. Candidates should be able to identify various types of lines and angles. That is the first one. We have lines and angles. Then candidates should also be able to solve problems involving polygons. Polygons is also there. Then candidates should be able to calculate angles using cycle theorem. Candidates should be able to identify construction procedures or special angles such as 30 degrees, 5 degrees, 60 degrees, 75 degrees, 90 degrees, etc. So let me quickly talk about lines. There are different kinds of lines. We have straight lines, we have parallel lines. So it is noted that if you have a straight line, let's say this is A and this is our B. If you look at this very well, discover that two angles are formed on a straight line. You can say that A plus B is definitely equal to what? 180 degrees, because the sum of angles formed on a straight line is added up to what? 180 degrees. I know we should, or we ought to have done all this in our previous lessons. I'm only trying to explain, just to refresh your memory on what you have done in your previous lessons. Also angles. So when we talk about two lines of this kind, let's say you have L, you have M, and these two lines are parallel, then you have a transversal. A transversal is a line that is drawn across parallel lines. As long as these two lines are parallel, we need to check out for some angles. We call one vertically opposite angles. That one is very important. Also, corresponding angles. Then the last one here is alternate angles. How do you recognize all this? Vertically opposite angles are, if you are given this place as, let's say this place is A, this place is B, this place is C, this place is D, then let's say this place is E, this place is F, this place is G, and this place is H, for example. Now, if you are to talk about vertically opposite angles, then A is vertically opposite to what? B. Take note of that. C is vertically opposite to what? D. And that is what these angles are known as what? Vertically opposite angles. A is vertically opposite to B. C is vertically opposite to D. Take note of that. So if you are talking about corresponding angles, you have lines. The angle formed on this, you can see that the first line, there is an angle on top. The second line, there is an angle on top. So this one, the angle on top, that means A is corresponding to E. Take note, this one is formed on top, this one is formed. The one that is formed down, this one is formed down, B. So B is corresponding to what? F. Take note of that. This one is formed down, this one is formed down. You can see that now. Those two angles are corresponding. Then the alternate angles, those ones appear like Z. Take note, they appear like Z, something like this. So this one is what? Alternate to this one. That's Z. So let's see the one that we have here. Look at this. Z. So this Z, D is here, G is here. So D is alternate to G. Take note of that. Also, look at this. B is alternate to what? E. Look at this. It's another Z. B is alternate to E. So that is what. Then D is alternate to what? H. Take note of that. No. D is alternate to G. That's, we are talking about alternate angles. D, you can see the Z. So D is alternate to G. That one is acceptable. Then B is alternate to E. Those are the two alternate angles that we can have in that setup. But we can have more of corresponding angle. D is corresponding to H. D is corresponding to H. Also, C is corresponding to G. You can see that. So all these things we need to, I'm just refreshing your memory on what you have done in your previous lessons. So I think I've been able to agitate your mind on lines and what? Angles. So let me talk about polygons. 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 So we are talking about polygons. There are some important points that we need to note. Here we have what we call interior angles. Interior angles. We also have what? Exterior angles. Exterior angles. Now, the sum of all the interior angles or the sum of each interior angle of n-sided polygon, the sum of each interior angles of a n-sided polygon is given as n minus 2 bracket 180 or 2n minus 4 bracket 90. Take note of that. Why the exterior angle is 360 degrees. So there is a relationship between exterior angle and interior angle. Take note. Exterior angle plus interior angle is equals to what? 180 degrees. It's equals to what? 180 degrees. So in that situation, we need to note that. Then we have different kind of polygons, such as we can say quadrilateral is a polygon, pentagon, hexagon, heptagon, octagon, nonagon, and so on and so forth. Then we also have cycle theorem, which we need to also know. The first one, renowned one, if you have a circle, and let's say the center of the circle, a line that is drawn from one part of the circumference and passes through the center to the other part of the circumference, they call it what? Diameter. But a line that is drawn from the center to meet the circumference, they call it what? Radius. And we know that diameter is 2 times radius. So that means radius is diameter divided by 2. Now, if you have a circle and you have a chord, a line that is drawn from the center to meet a chord, bisect the chord and is perpendicular to the chord. Take note of that. That one is one of the theorem. Then another one is angle sustained at the center of the circle is twice at that end. Angle sustained at the center of the circle is twice that which is sustained at any point on the remaining part of the circumference. What am I saying? What I'm saying simply is that if you have a scenario like this and you have this, let's say this is the center of the circle. Oh, the angle that is here is twice this. That means if this one is A, automatically this one will be what? 2A. We know that theorem too. We also know that angle form in a semicircle is right angle at the edge. So if you have something like this and you have something like this, in this situation, angle form is 90 here. Take note of that. This is a semicircle. That's center O. So angle that is formed here is 90. It's one of those theorems. Then we also know that angle in the same segment, they are what? They are equal. Angle in the same segment are equal. So that means if this place is A, for example, automatically this place will be what? A, but because they are in the same segment. If this place is B, this place will definitely be what? B. That's angle in the same segment. I know you know all this. You are familiar with all this theorem. I'm only trying to recall. I'm trying to refresh your memory so that by the time we are faced with so many questions of this kind, trying to test our applications of this, then we will not find it difficult. Now we also know that angle form, we have a cyclic quadrilateral. Take note. We have a cyclic quadrilateral. We have a cyclic quadrilateral. And when they say a particular circle is a cyclic quadrilateral, what it simply means that these four sides are touching the circle. And the theorem is saying that the opposite angles of a cyclic quadrilateral are supplementary. So what it means is that opposite angles of a cyclic quadrilateral, as that means A plus B, must be equal to what? 180 degrees. Also, we have the angle which a